When the world heard a tiny voice whisper, "one small step," most people didn't realize the odds of a single human ever walking on another world were once thought to be astronomically slim. Imagine a nation racing against time, politics, and physics, while the planet watched a countdown that felt more like a prayer than a launch. In the early 1960s, the United States found itself at a crossroads, its confidence shaken by a rival's triumph. The question haunting the White House was simple yet terrifying: could America actually send a man beyond the sky? The answer would demand more than rockets. It required daring, ingenuity, and a willingness to gamble everything on a fragile machine hurtling through the void. As the sun set over Cape Canaveral, the stage was set for a drama that would reshape humanity's view of itself. The story of how America put men on the moon begins with that desperate spark of ambition, a spark that would soon ignite an entire nation. Did you ever feel that electric buzz when a big dream seemed just within reach? To understand why the lunar mission mattered, you have to step back into a world divided by ideology, where every scientific triumph doubled as a political statement. After World War II, the United States and the Soviet Union locked into a tense standoff, each eager to prove the superiority of its system. In 1957, the Soviets launched Sputnik, a humming metal ball that silently orbited Earth, a punch to the American gut. The shock was palpable: sudden college enrollments in physics, frantic government meetings, and a nation looking up at a sky that suddenly seemed foreign. By 1961, Yuri Gagarin completed the first human orbit, and the United States faced a stark reality: the prestige of space exploration was slipping away. President Kennedy, aware of the symbolic weight, delivered a televised address that year, declaring a bold ambition: landing a man on the moon before the decade's end. This pledge wasn't just about rockets, it was a rallying cry to unite scientists, engineers, and ordinary citizens behind a common purpose. The race to the moon thus grew from a scientific quest into a cultural battlefield, where every launch carried the weight of a nation's pride and its vision for the future. What would you have done if your country asked you to reach for the stars? At the heart of the mission lay a concept as elegant as it was formidable: a spacecraft that could launch from Earth, travel 240,000 miles, land on a dusty sphere, and bring its crew safely home. This was no simple extension of existing technology, it demanded an entirely new architecture. Engineers imagined a three-stage rocket powerful enough to breach Earth's gravity, a command module to serve as an orbital living room, and a lunar module that could hover and descend in the moon's weak gravity. Each piece had to perform flawlessly, because there was no room for error when the cost was human life. The program's name, Apollo, evoked the Greek god of the sun, a fitting metaphor for a venture aiming to bring light to the darkest reaches of human ambition. Within NASA, a culture of "failure is not an option" blossomed, yet paradoxically, the agency deliberately encouraged test flights destined to fail, knowing that each mishap revealed critical data. The most daring moment came when a massive white rocket, later nicknamed Saturn V, stood poised on the launch pad, dwarfing everything around it. Its 5 million pounds of thrust would dwarf a commercial airliner, promising to lift not just a vehicle, but an entire dream into the heavens. This vision turned science fiction into a blueprint, and the world waited with bated breath for the first step toward the stars. Can you picture a single engine roaring louder than an entire city? The path to the moon was littered with hard-earned lessons, many of them paid for in sparks and flame. In 1966, the unmanned Apollo 4 mission demonstrated that Saturn V could indeed lift a massive payload, but it also exposed a hidden challenge: the massive vibrations that resonated through the rocket, threatening to tear it apart mid-flight. Engineers responded by adding flexible joints and redesigning the engine mounts, turning a potential catastrophe into a stepping stone. Then came Apollo 8, the first crewed flight to leave Earth's orbit and circle the moon. As astronauts Frank Borman, Jim Lovell, and William Anders gazed upon the barren landscape, they recited verses from Genesis, a haunting reminder of humanity's smallness amid the void. Yet the mission also uncovered a subtle, perilous problem: the lunar module's descent engine, designed to land softly on an airless world, produced a thin, invisible plume that could kick up dust and obscure visibility. On the ground, a young engineer named Gene Kranz, later known as the Gray Man, began compiling a meticulous checklist that would become legendary for its precision. These moments, each a mixture of triumph and flaw, served as the crucible in which the Apollo program forged its resilience, teaching the team that every failure was a clue, and every success a fragile gift. Have you ever turned a mistake into a breakthrough? When Apollo 11 finally lifted off in July 1969, the world felt the tremor of a momentous gamble finally paying off. Inside the massive Saturn V, 3 astronauts, Neil Armstrong, Buzz Aldrin, and Michael Collins, embarked on a journey that felt more like a pilgrimage than a trip. The ascent itself was a ballet of fire and engineering, each stage shedding like a snake's skin at precisely calculated intervals. Yet the most critical drama unfolded far from Earth, in a cramped lunar module nicknamed Eagle. As Eagle descended, a cascade of alarms blared, warning of computer overloads that threatened to abort the landing. Armstrong, faced with a boulder-strewn field, made a split-second decision to guide the module toward a nearby crater, a maneuver that required manual piloting with mere seconds to spare. The descent engine throttled down to a daring whisper, and the lander touched down with a gentle thud, the iconic message, "The Eagle has landed," echoing across the globe. This narrow escape revealed the razor-thin margin between triumph and disaster, reminding everyone that even the most sophisticated technology depends on human judgment. In the days that followed, the astronauts conducted experiments, collected rock samples, and placed a flag that would become a symbol of perseverance. The mission's success rippled outward, inspiring generations to imagine possibilities beyond the horizon, while also exposing the bitter reality that each step forward required an equally great willingness to risk everything. Would you trust a computer with your life in a life-or-death moment? What many people overlook is that the lunar surface holds secrets that even the astronauts didn't anticipate. For instance, the moon's regolith, its fine, powdery dust, proved to be an unexpected adversary. The fine grains cling electrically to surfaces, and when the astronauts moved, the dust stuck to their suits and equipment, eroding seals and threatening the integrity of their life support systems. NASA engineers later discovered that static charges could cause tiny arcs of electricity, a phenomenon that could have sparked fires inside the spacecraft. Another surprising fact concerns the moon's far side, forever turned away from Earth. Early radio signals showed that this hidden side experiences a constant radio-quiet environment, undisturbed by Earth's electromagnetic noise, making it an ideal place for future deep space communications, an insight that only emerged after the early Apollo missions mapped the terrain. Lastly, the moon's gravity is only 1/6 of Earth's, which might sound like an advantage, but it also means that any small push can send a spacecraft drifting away indefinitely. The astronauts had to master a delicate balance, using the weak pull to their advantage while never letting it become a trap. These subtle challenges highlight how even an apparently barren rock can surprise the most prepared minds, reminding us that space exploration is as much about uncovering the unknown as it is about conquering the known. Did you ever think a quiet, dusty rock could be so dangerous? The ripple effects of landing on the moon can be felt in the most ordinary corners of American life today. Consider the tiny microchips that power our smartphones, GPS units, and even the pacemakers that keep hearts beating. Their origins trace back to the integrated circuits NASA demanded for the Apollo guidance computers, machines that needed to be both lightweight and reliable under extreme conditions. That push for miniaturization sparked a semiconductor boom, turning Silicon Valley into a global technology hub. Meanwhile, the heat shield tiles that protected the command module from the sun's blistering rays inspired the development of advanced insulation materials used in everything from fire-resistant clothing to energy-efficient building designs. Even the humble cordless drill owes its lineage to the cordless power tools created for astronauts to assemble equipment in the weightless environment of space. Moreover, the image of a flag planted on a distant world ignited a cultural imagination, influencing art, literature, and the way American children picture their futures. In classrooms across the country, teachers still point to the Apollo missions as a testament to what can be achieved when a nation invests in science education and daring ambition. These everyday technologies and cultural shifts underscore that the moon landing was not just a single event, but a catalyst that reshaped the fabric of American society in ways most of us never notice. Can you remember a piece of tech you use daily that traces its roots to a space mission? Two myths about the moon landing continue to linger like dust on a forgotten rover. The first insists that the landing was staged on a Hollywood set, complete with a wobbly flag and fake shadows. Yet the physical evidence tells a different story. The retroreflectors left on the moon's surface still bounce laser beams sent from Earth today, providing measurable proof that humans placed objects there. Additionally, the flag appears to flutter not because of wind, there's no atmosphere on the moon, but because of the momentum imparted when astronauts twisted the pole, a motion that slowly dampens in the vacuum. The second misconception claims that the United States achieved the moon landing without any Soviet contribution. While the US led the overall mission, many of the technologies, such as the early cryogenic engines, were derived from research shared during the Cold War's occasional scientific exchanges. Even the critical quartz crystal oscillators used for timing were initially developed in Soviet labs before being adapted for American spacecraft. These clarifications remind us that history is rarely black and white, achievements are often built on a tapestry of global knowledge, even amid rivalry. By dismantling these myths, we see a clearer picture of human ingenuity and the collaborative threads woven through one of humanity's greatest feats. Ever wondered how much of what we consider American owes a debt to international input? Looking ahead, the moon is no longer just a destination for a daring few, it's becoming a stepping stone toward a sustained human presence in space. Private companies, fueled by the same spirit that drove Apollo's engineers, are now developing reusable landers designed to ferry cargo and crews regularly. NASA's Artemis program aims to land the first woman and the next man by the mid-20s, leveraging modern computing power, three-dimensional printed habitats, and lunar in-situ resource utilization, most notably extracting water ice from shadowed craters to create rocket fuel. This shift from one-off missions to a lunar economy could spark a new era of mining, scientific research, and even tourism, transforming the moon into an off-world laboratory where experiments in medicine, materials, and agriculture can be conducted without Earth's interference. Over the next decade, the lessons learned from Apollo's triumphs and tribulations will guide engineers to design systems that are more autonomous, resilient, and cost-effective. The vision extends further still, a lunar gateway serving as a staging point for crewed missions to Mars, turning the moon into a bridge between our home planet and the red planet. In this unfolding narrative, the bold gamble of the 1960s proves its lasting value, shaping a future where humanity reaches farther than ever imagined. Would you travel to a lunar hotel if it opened next year? The story of how America put men on the moon is a testament to what can happen when urgency meets imagination, when a nation decides that the impossible is worth pursuing. From the trembling rockets of Cape Canaveral to the quiet dust of the lunar surface, each piece of the puzzle was forged by countless individuals who dared to dream beyond the horizon. Their legacy lives on in the devices we use, the scientific knowledge we share, and the aspirations of a new generation ready to set foot on distant worlds. As we stand on the brink of another great leap into space, remember that every great achievement starts with a question, a risk, and a willingness to fail forward. If this journey sparked your curiosity, please hit the like button, share your thoughts on what humanity should explore next in the comments, and don't forget to subscribe for more stories that illuminate the bold edges of human ingenuity.